Okay, let's try this 2D trig proof thing with no numbers, non-numeric. It's all letters, and some people don't like it with all these variables, and it makes it a little difficult, but let's just give it a try. Okay, we're going to prove, I'm actually just going to do this section. Once you've got this formula, you just take these numbers and plug them in there, and you get your answer. So this part's really easy. Okay, let's try. Well, we've got a tower here, and there's this point. ST is called D. This angle here that bends up all the way is X, and the angle right here, CDS, is just Y. Well, there's some angles we can figure out. Look, we've got to use D, and it's the law of sines is the way this thing works a lot. But there's X, there's Y. What if we go X minus Y? Then we get that angle right there, SDT. That's X minus Y. We need that to get started. And this angle up here, hey, look, that's 90. That's Y. That's 90 plus Y. That's the exterior angle of triangle CSD. So that's 90 plus Y. Now that's going to help us. Now, the first thing we're going to do, we look up here and we say to ourselves, okay, there's something that's kind of happening between these two triangles here. There's kind of a link, but we can get at this part here, this dt. See, there's cosine of x. See this big angle here? Well, dt is the key because it's part of the big triangle, and it's part of this non-right angle triangle that we're going to use. So we've got to use dt. Well, we've got x, so the cos of x is CD over dt. The cos of x is dc over dt. Adjacent over hypotenuse. Well, it's that easy. Now we've got dc. dc equals dt times cos x. Well, that's your first step. You know, you've got to have cos x somehow in there. And you're going to use dt because it's part of the big right angle triangle and it's part of this non-right angle triangle, TSD. Okay, now it's just law of sines, except now we've got x minus y. Well, d goes with the sine of x minus y, and dt goes with the sine of x 90 plus y. We figured out that's 90 plus y. So we can make the law of sines. dt goes with the sine of 90 plus y. D goes with the sine of x minus y. Oh, look at this. D over sine minus x minus y. Gee, it looks like we're almost to the answer. But the sine of 90 plus y, oh, that's a cofunction. Sine's positive up there, and we switch sine to cosine. Then it goes up here. Let's see. So this is going to go up here. It's going to be d cos x. Gee, we've almost got our answer. Let's take a look. D, cos y. It's cos y. We've got the d cos y. We've got the sine x minus y. Well, that's what dt is. Well, we've got dc equals dt times cos x. All we do is take this dt and substitute it in there. And what do we get? We get dt times cos x. Hey, cos x times cos y. That would just go in here. That gives me the answer. I could write it out again, but I've just proven that dc equals this. Just plug these numbers in here to get 2 more marks. You know, it says TS is 50 meters. Oh, maybe it's a little harder than that. It says X is 24.5 degrees. Y is 17. So it's a little bit more work. But X minus Y, oh, it's not too much more. You might have to do a little bit, but it's mostly just plugging in the stuff here. I don't think I'll go through that. The hard thing was proving this thing here. Well, I hope that helps.